Howdy folks. All right, what we're going to do in this particular video is I'm going to show you how to do what is called solving a system of equations, okay? A system of equations. Now a system of equations is a situation where you have two equations and each one of the, well, at least one of the two equations has two variables in it. Now, you may recall when we first started solving equations in the other class, or the other day, that I said that in order to have a solution, you have to have at least as many equations as you have variables. And I said that if you only have one equation but two variables, you can't have a solution for each of the variables. There are an infinite number of possible solutions. But if we have two variables and we have two equations that are related to each other, meaning they're set as one thing. And in what I mean by set as one thing is that the solution for x and the solution for y, the value of x and the value of y, have to be the same in both equations. Whatever number is the solution for y here is also the solution for y up here. Whatever number is the solution for x here is also the solution for x up here. And that's why I'm bracketing them together, okay? Now I'm not going to bracket them together in all the problems. I just want to show you that they are one thing. They are, instead of being two separate equations, they are one system of equations. They work together, okay? Both of them have to be true at the same time. And there are three main ways that we typically learn how to solve a system of equations in an algebra class. One of them is solving by graphing. One of them is solving by substitution, which I'll do next. And then the last one is solving by elimination, and I'll do that third, okay? So let me show you how to solve a system of equation by graphing. Now, I need to warn you this. Solving by graphing really only works, it really only works if your solutions are both whole numbers. They're both integers, okay? So x is going to, not a fraction, meaning it's not a, if it's a fraction, it's an integer fraction, like 12 over 6, and it becomes 2, okay? So x and y need to both be integers in order for solving by graphing to work really, really well, okay? Because what's going to happen is we are going to draw the line for this equation and the line for this equation, and wherever they cross over, whatever the x and y coordinate of where they cross over is, that is the solution. And on a graph, it's hard to see fractions. It's hard to know what the value is on a fraction on a graph, okay? Unless you have an electronic graph where you can zoom in and see the solution, okay? So here, here's the procedure, and we're gonna go through the procedure to solve this system of equations. And as you can see here, I have a coordinate plane, so we can graph both lines here. The first one, step one, is solve for y in both equations. This puts them into slope-intercept form. Well, you can see that our system is already solved for y. This is already in slope-intercept form, and this is also in slope-intercept form. So step two is graph both lines. So we just learned how to graph the equation of a line in slope-intercept form, so that's what we're going to do right now. And I'm going to use this ruler to draw the straight line. So we're going to graph y equals 2x plus 5. So it has a y-intercept of plus 5. So we're going to go up 1, 2, 3, 4, 5, and we're going to put a dot. And then it has a slope of 2. So that means that we're going to go up 2 and over 1. We could do it again, up 2 over 1. We could also go down 2, back 1. And now, but I really only need 2 points. And then what I'm going to do is I'm going to line them up and draw a line. Let's make sure I got these lined up, lined up, lined up, lined up. And now I'm going to draw a line. There we go. And that is the first line. I'm going to do the second line in a different color. Let's do purple. This one says y equals negative 2/3 x minus 3. So we're going to go to the y-intercept -3, 1, 2, 3. We're going to plot that. And then our slope is -2 over 3. That means down 2 and over 3. Down 2 and over 3. I can do it again, down 2 and over 3. I can also go up 2 and back. Oh, there's our solution right there. And now I'm going to line them up and draw the line. And then it says, identify the XY values, the XY values at the intersection point. So where do they both intersect? They both intersect right here. And that looks like 1, 2, 3 back and down 1. So that's -3 and -1. So -3 and -1 is the intersection point. That means our solution is x equals -3 and y equals -1. And that is our solution for this system of equations. Let's do another graphing example. All right, here's another example. We've got y equals 1/2 x minus 3 and y equals 3x minus 8. It's a system of equations. Let's graph both lines and find out where they intersect. So the first one is 1/2 x minus 3. So from the the origin will go down to -3. There's our y-intercept. And then the slope is positive 1/2. That means up 1 over 2. Up 1 over 2. Up 1 over 2. Maybe we go down 1, back 2. There we go. Puts them right in a straight line. Line them up. Go. And draw the line. I got kind of messed it up there for a minute. There we go. There's the line. Get rid of this portion of it. There we go. All right. Now let's graph the other one. We got y equals 3x minus 8. So we'll go to 1, 2, 3, 4, 5, 6, 7, 8 right here. And then our slope is positive 3. So that's up 3 over 1. 1, 2, 3 over 1. Okay. And so let's line those two up, line them up, draw our line, and it looks like these two lines are crossing. By the way, any two lines are going to cross unless they're parallel or unless they're the same line, but then that's just one line. Okay? So as long as you don't have the same slope on both of these, if you have the same slope on both of these, you're going to have a problem. Okay? Cannot have the same slope on both of them, okay? Otherwise, they'll be parallel. And you already learned that. So look, they intersect right here, and that's the point, that's positive 2 and -2. So x equals positive 2 and y is equal to -2. That's our solution to our system of equations, okay? Let's try a third one. All right, here's another system of equations. We got y equals -x plus 5 and y equals 2x minus 1. The slopes are not the same, so that means they're going to cross over at some point, so there should be a solution. Let's graph the first one. Y-intercept is positive 5, so from the origin, 1, 2, 3, 4, 5. Plot that point. And then there's a slope of, this is -x, that's -1x. That's a slope of -1. So that's down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay? All right. All right, so there's -x plus 5. Now let's graph 2x minus 1. So we'll go to the y-intercept, -1. So from the origin, we'll go down 1. Then we'll go up, we got a slope of 2, up 2 over 1. Up 2 over 1. Up 2 over 1. There we go. Line them up. There's our line. Do we have a solution? We sure do. Can you see where they intersect? Right here. That's from the origin, 1, 2, and 1, 2, 3. So x is 2, y is 3. So x equals 2, y equals 3. And so that's our solution. Okay? Let's do another one. All right, here's another system of equations. We're going to graph it. They do not have the same slope, so that's good. They will intersect. I'm going to do one extra step on this problem after we get our answer. our x and our y values, we're going to plug them back in and confirm that they in fact solve the system. Okay? So this first one here, negative 3/4 x plus 1, we'll put the y-intercept at positive 1. From the origin, we'll go up 1. The slope is negative 3/4. That's down 3 over 4. So down 3, 1, 2, 3, over 4, 1, 2, 3, 4, negative 3/4. So we'll line those up and draw a line. Okay. Now let's go to this other one, y equals negative 3x minus 8. So I got negative 8 there. From the origin, 1, 2, 3, 4, 5, 6, 7, 8. Almost messed that one up. Then our slope is negative 3, so that means we're going to go down 3 over 1. But look at this problem here. I can't go down 3 and over 1 because I don't have a line right here. Now I want to be very careful. I got to get the precise point in order to draw the graph. So instead of going down 3 and over 1, I'm actually going to go up 3 and back 1. Up 3 and backwards 1. See, when I go up 3 and backwards 1 means negative 1. 3 divided by negative 1 is negative 3. So I still have a slope of negative 3. So I'm going to go up 3 and back 1. And I'll put it right there. Now I'll line them up. Let's see here. Get them lined up right there. And draw my line. And now watch this. Look at this. There's the intersection point. Now if you look real close, which you might not be able to from there, but it doesn't quite intersect at this little, what one of my students calls a baby origin, okay? But it looks to me like maybe it should be intersecting there. So what I'm going to do is I'm going to go back. The slope here is down 3, forward 4. So that means backwards 4 and up 3, and sure enough, that line is actually supposed to be going through that point right there. So that's the solution. This is what I mean when I say that you really should have whole number answers if you're going to do a graph. Otherwise, it's really hard to see what the fractions are. If your answers are fractions, you should try elimination or substitution. Okay? And you can do elimination and substitution on those. You can do any one of the 3 methods on any system of equations, but I want you to know how to do all 3. So that point right there is 1, 2, 3, 4, negative 4 and 1, 2, 3, 4, negative 4 and 4. So solution here is x equals negative 4 and y equals 4. Now just to confirm, we can plug these numbers into these equations. If I plug negative 4 into this one up here, I got negative 3/4 times negative 4 and then plus 1. Well, negative 3 over 4, negative 3 times negative 4 is positive 12. So I got 12 over 4 plus 1. 12 over 4 is 3 plus 1 equals 4. Y equals 4. Success. Now let's try this one here. If I put a negative 4 in here, negative 3 times negative 4, that's 12. Minus 8 is also 4. So I have a solution. So I can check my solution by plugging my x and y's into both of the equations and showing that they're true. Okay? All right. Let's just do a couple more, okay? All right, here's another system of equations. Why don't you pause the video and try this one on some graph paper yourself? Okay, so let's see if you got the same thing. Let's see if I get the same thing you got. The first one is 5x minus 4, so I'll go to y-intercept of negative 4 from the origin. 1, 2, 3, 4. Okay. And then this one has a slope of 5, so I'm going to go up 5, 1, 2, 3, 4, 5, and over 1. And just in case, I'm going to go up 5, 1, 2, 3, 4, 5, and over 1 more time to make sure that I get a good set of dots that I can draw through. There we go. Nope. There we go. Yeah, it's pretty good. Let's draw right through there. There we go. There's that line. Now let's try this other one. Has a y-intercept of positive 7. Positive 7. So I'll go from the origin 1, 2, 3, 4, 5, 6, 7. Put a dot right there. This one has a slope of negative 1/2. That's down 1 over 2. Down 1 over 2. And look, there's the intersection right there. We're actually going right over top of one of our dots. Let's line them up. And draw our line. And sure enough, there we go. There's our solution. Looks like from the origin, 1, 2, x is 2, and 1, 2, 3, 4, 5, 6. It looks like 2, 6. X is 2, y is 6. Negative 1/2 times 2 is negative 1 plus 7 is 6. That's correct. 5 times 2 is 10, minus 4 is 6. And so we check our solution. Okay. Let's just do one more, and I'm going to want you to do this one on graph paper before me as well. All right, here's another system of equations. Get some graph paper, pause the video, and you graph this one. Okay, so I'm going to graph them now, see if I get the same thing that you got. The first one, my y-intercept is negative 4, so from the origin down 4, 1, 2, 3, 4, put a dot there. My slope is positive 2 over 9, that's up 2 and over 9, so up 2 over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Put that dot right there. I'm going to go down 2 and back 9 also. Down 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to put a dot right here, and this is going to make sure that I get lined up really well to draw this line. Yeah, that should turn out pretty good. Keep the ruler from moving while I'm drawing it. It stayed pretty stable, so we're good there. Now let's graph the second one. The y-intercept is positive 1, so from the origin I'll go up 1, and then the slope is negative 1/3. That's down 1 and over 3, so that's right here. Let's line them up. I think I can see what's about to happen. There we go. And there we go. I can see where they intersect. They intersect right over here, right? And so that is from the origin, 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 2. So 9 and negative 2. So x equals 9, y equals negative 2, and that's our solution. Okay? That's it for solving a system of equations using graphs. And now let's move on to solving a system of equations using substitution.